Hello, in this video I'll be mainly talking about how to produce engineering drawings in Fusion 360. I'll be talking about the proper standards and the views we are using to reflect some parameters and properties of a model that we developed. The reason I said I'll be mainly talking about this, I will also reinforce some of the learning material we discussed so far and how to revise the CAD model and the related properties and details before we go into this documentation process. Because drawings are how engineers or designers communicate with the other stakeholders. So therefore, we need to ensure we are including the proper set of data inside the drawings. Okay, I'm going to start this off by introducing you to some different kinds of views. Namely, I'm sure you have seen this before, but probably not knowing what exactly the differences of them. So there's a little simple sketch here. I got a light source and I'm projecting that as at an object. Then behind there I got this shadow. Okay, so depending on the light source position and where you stand, the shadow you're going to see is going to be different, right? So depending on that variables, there are four primary types of projections. So one is orthographic. That means you are shining the light directly at it, perpendicularly on these faces here. So if you perpendicularly shine on the front view, then you got the front side view. So we call them orthographic views. In the next slide, I'll explain them further. Then there's another one called isometric. So in this isometric, you are going to see three sides. We have the object on equal inclination to the projection. So this way it can give you a good understanding about the overall shape of the object, but it will not give you some very detailed dimensions or parameters of that object. But on the other hand, the orthographic I was talking about, since it was directly looking at one face, uh, it's just isolating the properties on that particular face. There's another one called oblique that we don't really use that very often. We are looking, there's one perpendicular side, then the other one is slanted. The last type of projection view called perspective. I'm sure you have used that word, you have heard that before many times. So that is basically how the human eye going to see the surrounding of ours. So the observer at finite distance with rays converging. So imagine yourself sitting in the middle of a rail tracks and the tracks are stretching towards the infinity. Let me help you imagine that. There you go. So that is a good example of perspective view, how you naturally observe your surrounding, and also something like that. So this type of views, this type of drawings are predominantly used by concept designers, because this is the best way to communicate the realistic relationship of the objects you have placed within the drawing. But in this level, what's more important for us to learn is orthographic views. So there's this analogy of this glass box. So the named faces we have in this cube, uh, depending on which face you're looking at, it can show different properties of that object. So if example, if you look from this top view, you're going to see the width and the depth. Front view is going to show the height and width. How these front, top, right views are decided depending on which planes you select when you model this object. But that doesn't mean whatever you have developed on the front plane must be the front view of the drawing. Fusion 360 and all the other CAD modeling software allows you to bring your model into the drawing area and you can label as how you like and reorient and automatically create the corresponding projections, so you can add the dimensions as you wish. So but as a general practice, you select the front view as the side that has most of the important features. Example, in this case, I have this height, width, and there's this cut as well. So this is the face. When you look from that side, this is a face that has most of the detail. So as a general practice, we use that as a front view. But anyway, the whole goal of the drawing is capturing all the details from different angles, so that when you give it to a manufacturer, they can produce that for you. Okay, so now we just discussed about the introduction. So let's go to Fusion 360 and make some drawings. All right, so I got here our old friend. So this is the assembly we just assembled inside Fusion. So I'm going to show you these two kinds of drawings. So number one is assembly drawing. So this whole thing is going to be inside one drawing, and it's going to show you what are the different components of that assembly. The second part is the part level of drawing. So in that way, I'll pick one of these objects. So in this case, I'll pick this holder. I'll do some modifications to that, and that will be the part level of drawing. In that level, I'm going to include all the dimensions and whatever the information a manufacturer will need to produce this product for us. Okay, all right, so let's start with the assembly drawing first. So in that journey, there will be some modifications I'll be doing for this assembly, because remember when we were doing this model, I didn't go that much detail into the documentation part. I didn't have that in my mind, because I just want to show you important things that related to parametric modeling or whatever the other operations I was talking about. So in that process, I'll be doing some editing into this assembly. But when you work on your project, you can integrate that, and as you develop from your model from scratch, you can include these practices to that. All right, okay, so I have this assembly here. I can go to the data panel. That is where all of them are saved. I can start from here itself. Just simply right click on that model assembly which you want to create the assembly of, and new drawing from design. Click on that, then there will be a new tab will be opening with that model. There it is. Okay, so it has picked up some information already. Assembly test is a name I had given for the file, and also the created by name, and also the date as well. So if you want to change this document, you can always click on that, double click, then you can enter the detail here, John Smith, like that, and just say OK. Those information will be added to that. So generally you have a drawing number. In industry, they will be following a certain set of kind of naming convention. Okay, so this is a sheet here. That's an A3 sheet. Later on, I'll show you how to select sheet type and everything. Okay, so now I can bring the views here. Now, Fusion already knows I'm making the drawing of this assembly here. So I can bring that here. So I can bring a base view, click, there it is. Now it's coming like this. Notice it has picked up the front view. If I go back to this drawing, and if I click on my that's left front view, that's the front view. But we have made a mistake there, haven't we? So actually this is what we meant to be the front. So that's no problem when it comes to the design. We don't have to stick with this front here. We can go back to the design here. I click on that. Now in this drawing view, this palette here, I can change which view I want. I can say the orientation, not front. I'll go with back view. Then now it's flipped correct to the correct side. Then I click in the place I want. Done deal. And one other thing here, scale. 1 to 2 is a shrink down version of it. 1 to 1 is going to be slightly bigger, but I don't think I can accommodate 3 other views in this size. So I'll go with 1 to 2. There you go. That looks good. I'll say OK. When I say OK, notice the style here. By default, it's going to go visible edges and visible and hidden edges. Then you got shaded and shaded with hidden edges. I'll go with the default one, and I say OK. There you go. So that is the default view. So since these drawings go with the black and white, and so having the need the ultimate clarity, we try to reduce this unnecessary lines as much as we can. If that necessary to show some dimensions or some other details, then we definitely include them. Then we want the projections. Then we got projected views. Click on that button, then click on the view that you want the projections of. You will see what I mean by that. I click on this. Now when I move your mouse upward, it's going to show me the top view of it. Remember that glass box? It follows the same order. If I go sideways, it show me the left side view, right side view, bottom view. So from one of the primary views, you can project all the other views. Okay, so I'll go this side and also top view. There you go. And also one isometric as well. There it is. So then once you finish with that, press escape key and you're done. So you can move them, just simply click on that. There will be a box appearing in the middle. You can move them. Notice these perpendicular views, only you can move along that axis because they maintain that relationship, that projection. Notice here. That's only you can do. But the isometric, no problem at all, because isometric is basically showing the, it's more like you don't usually go with the perspective, but isometric provides a overall picture of the object. In general, you give isometric the shaded view. So double click on that, double click on any view, then you can have the properties palette. I'll go click on shaded and close. And you can also change the scale of the isometric if you like. Make it 1 to 1 and that's slightly bigger. I think that's gonna be a bit too big, but that's fine. Okay, that should do. Okay, so what do we include? What else we're going to include in the isometric view? It depends, depending on the level of detail. Sometimes we just leave as is like this, and most of the time we include most of the primary information, primary dimensions, like as an assembly, how much space is going to take. Example like this. So I'm going to show you how to add the dimensions here. It's right here. Dimensions, linear and align. So what the difference of these two is, when I go linear and I click on this line and whatever that, so you can see that's not in a vertical line though. That's not in a clear vertical line, but still when I click on that, the dimension line is going to be on the the vertical dimension. It's like you measured exactly from this top to right the point just in a horizontal line with the line I clicked. But if I go with the other way, if I go with aligned, click, and if I pick the same point, now it's showing me the aligned dimension. Notice they are slightly different. Probably it's not the best example, but I hope that gives you an idea on that. So in this kind of a case, you will go select the linear dimension, and for the width, I'll go pick a point somewhere the farthest to the left and pick a point farthest to the right. And I need this one here. Oh yeah, that one if I did with aligned, notice what happened. Click there and click here. This is the dimension I'm gonna get. Okay, I don't think that is very important there. So those are the dimensions, and we are missing one, right? So this way, from if you look from this side towards the backward, so that dimension is taken from the other view. Linear, I can pick one of the top points there and another point from this bolt. Okay, and there you go. Let go. And this view, I don't think it's going to provide any useful dimension because all the three dimensions already covered here. So I don't want any more other information. So I'll just leave it there, leave it as is. Then the other important thing is, so make sure you go escape, can bring it in, double click. You can change the visual style, hidden edges. At least it will show you some more details there. Move them closer a bit. Okay, I can show you very important feature that is going to get included inside an assembly drawing, which is called the bill of material. It's basically a table, or we can say table of contents, that list all the objects that included inside that assembly. So let's add that by simply clicking click on the tables button here, click on that. Now you can see it has already some rows included there, and you can see just try to snap onto this corners here. I'll go to the very top left, top right corner and let go. There it is. So now it shows me a list and also automatically created balloons. So it's pointing at all the different components we have in this drawing. So number one is the hammer, number two is a hanger, hammer head, and also the screws. And I'm missing some lines here. You can see the description is missing, and there's another problem here. I got 4 screws, right? But it's showing me only one. Okay, so let's see what has happened there by going into the assembly. Alright, so go to the assembly here. Okay, so each of these components are gonna get listed in my drawing here. Remember, components, not the bodies. Okay, so first look at the description. So if I looked at the hammer here, so I right click and I can go to properties, and the properties window, there is an entry to add a description here. So I can say mini hammer. When I say OK, that is saved there. Same thing, the hanger, properties, wall mounted hammer hanger. Say OK. And these bolts. Properties, M6, M countersunk 25 mm flat head bolts. Say OK. And hammer head, properties. Oh yeah, that has to be added in that model itself. So it allows me to add descriptions only on the components we made inside. Okay, so only thing you need, if you wanna do this one, so you need to go to that object, to open. It will be opened up in a new tab. There it is. Now we can go right click. So in that case, I'm just gonna right click on the main header here, because that is the master file. Properties, uh, I think we set as brass, even though it says steel here. While we are here, let's go ahead and change the material as well. Got physical material. So appearance is different. So the appearance basically just gonna give the look of that metal. Okay, but the physical material is actually setting up that material. Then all the properties going to change based on that. So metals, metal, I think, okay, let's go down. Aluminium, brass, I think that was some bronze. Let's let's go ahead with bronze. Applied on that, close. Okay, so then the magic happens in this drawing here. When you go the link, oh, I didn't save it. Make sure you need to you're saving all the changes you make. You need to save in order to apply them. So I'll save it here. Important stuff. And in the description you want to give for that version, mat change, material change, and I save assembly here. Okay, I see we got some changes here. Right click, get latest. Come on, it's doing that. Okay, and save it, and add disk description. Save it. Now go to the, when you go to the drawing, you can see there's a symbol here, reference assembly test, and the link, there's a mark here. So click on that. Now it's going to update. It might take some time, maybe a couple of seconds. There it is. It's going there. Oh, okay, look what happened here. So I got all of them are populated here. Description already added to the bill of material, and also the material here. So we can change the table to give the space. So you can adjust that, so it's gonna look good. Okay, one last thing that I don't really like in this is this part, the number of balls. I got only one showing here. Let's find out what is the mistake we have made on this, and let's learn that. So we when we do our modeling from the beginning, let's do it in the proper way. Okay, so I'm going back to my assembly here. All right, so I'm seeing, okay, I'm looking at the list, parts list here. Okay, this is the bolt. Okay, I got only one, that's right. But when I click on them, all four of them getting selected. That is not how it should be, because they are four different components. So when I open this up, open that component up, and I got the bodies. I got 1 2 3 4 of them here. Remember, when we duplicate them, what we just did, we mirrored them across. So when we mirror them, if they don't go as components, they just copy as bodies. So you need to avoid that when you develop your models here. So the best way to do that, I think I vaguely remember I showed how to do that, like a copy paste. So that is how you're supposed to do that manually. I mean, individually, you need to have made them. Okay, so let's see how I troubleshoot this. I'm just going to leave it alone here, and I'm going to show you the important feature of this timeline. So we can go back in time. All right, that sounds very cool, but I'm talking in this design sense. We can go back in time like this in the time bar. So at the very right corner, you got this cursor kind of a thing, the current time marker. You can go back one level. Now you can see the bottom level, the mirror is hidden there. You can go one level back and that one is gone. So that is where we need to stand. So from there, it's pretty much so we are in that level now. We can add another feature into this now, and your design can continue from there. Okay. Okay, so now let's go back into this, expand this one. Bodies. There you go. I got only one body. This only this one here. Now what I'm going to do, I'm just going to click on that. Control C, Control V, and you can pull it out. Okay. Notice now that I created a new one here. So I have tried this one before, therefore it's showing me number 4. But in your case, if you do it for the first time, it should show me number 2 here. This means exact same component. This is that number, which one is that? 1, 2, 3, 4. Okay. Before I go ahead and join this here, I'm going to mirror this hole here. Okay, so let's see. Let me recap you on that. Go ahead and unhide those two planes because those are the ones we use for mirroring, and go to create mirror, select that hole, select that feature. Actually, before you go there, remember we are doing all this in this assembly. You can always activate this hanger component. Each and every component we can activate individually by simply clicking on this radio button, hanger. There it is. And you can see the timeline only for that. Okay, I'm going to create mirror. I select that whole feature. Notice how easy to find that. Actually, this is the mirror of that hole. So I select both of these, and mirror plane is this guy. There you go. Now I selected all of them now. Cool. So now we can go back to assembly. So I can click on that assembly. Now I have all of them here. Okay, simply I got one of these here. I can click on that. Control C, Control V. Then Control. Okay, just say okay. Let's do one at a time. Control C, Control V. I got 3 of them. See, now I have different components here. 1, 4, 5, 6. Okay, so individually I can add them, join them into this object. I can simply hide those back. Click on this, go to join. Click on this outer edge, this edge, and boom, that's done. Say okay. Join edge, this edge. That's done. Okay, last one, join. Done. Done. So there are ways to do all of them in one go, but I just want to have the process reinforced to you multiple times. Okay, so now I got 4 different components. So now it exactly how it come together physically. I got a number of components is equal to the the actual number of components. Save this one. Don't forget to save. That's important. Components correction. Done. I go back to the drawing. Pay attention to this quantity number here. Okay, and I click on this button. It's updating. It's updating. It's updating. There it is. Okay, so now I got 4 countersink bolts. So here it doesn't reassociate. Okay, so the because there was a change with the number of them, so number of objects, it didn't like that balloon I had here. So I can simply delete that. Right, escape, click on that, delete. Same thing here, delete and redo that. So I can always add a new balloon by simply going into balloon and click on that object. There it is. Place the balloon, number 4. And the dimension as well, linear dimension, to the very top, and that balloon. There you go. Okay, so that's how we create an assembly drawing. In the next video, I'm going to show you how you go into the part level and create a very detailed drawing for a selected part. All right, I'll see you in the next one. Thank you.